I am Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I am going to discuss about the topic plane waves in good conductors, which is studied in the Unit 5 plane electromagnetic waves in the subject electromagnetic fields and waves in the second year students in the 4th semester. Today I am going to discuss about the topic for the discussion. Today I am going to discuss about the good conductors and how the Maxwell applications equations are applied in the good conductors, and the wave equation related to the good conductors, and propagation constant, which is gamma, which is related to the attenuation constant and phase shift constant. And keeping the Maxwell equation related to the good conductors, we have to derive the skin depth and intrinsic impedance, which is eta. And overall the application will be discussed related to our plane waves in good conductors. The empathy part of the good conductors which is having the material and it is having the conductivity which is sigma less than greater than equal to omega epsilon, where epsilon is a permittivity and omega is a angular frequency, where the copper and aluminum material will be having the good conductors compared to other materials. In the copper, which is having the sigma which is greater than omega epsilon, and aluminum also having the higher conductivity, which is exhibiting the conductivity with the conduction current plays a vital role in both the materials. In the when the copper and aluminum will be used in the conductors, the conduction current will be plays a vital role, and therefore the conduction current will be related to the displacement current. So the material electrical behavior will be primarily changing with due to the carrier movement of this carrier movement and related to the conductivity. The conduction rate, conduction current will be dominating the displacement current, and the current density which is related to the conduction current density and displacement current density. When there is some good conductors, copper and aluminum will be exhibiting the conduction current over the displacement current, so that the copper and aluminum will be used in plane wave construction. And the defined part, how the Maxwell equation will be applied to the good conductor. In a good conductors, applying the Maxwell equation, we have to derive the two equation which is related to the electric field and magnetic field. The electric field which is related to del cross E vector, which is equal to minus mu dou by dou t of H vector, and coming to the magnetic field, del cross H vector, which is equal to sigma E plus epsilon dou by dou t of electric field, where this both equation will be included in the good conductors, and it will be producing the conduction current term as well as the displacement current term. When using this Maxwell equations, the conduction current will be dominating our displacement current. And ideate part of the derivations of the wave equation, keeping this Maxwell equation del cross E vector and del cross H vector, we can derive the Maxwell equation which is related to del cross E vector, which is equal to mu epsilon dou by dou t of E vector plus mu epsilon dou square E by dou t square, which is related to the attenuation constant as well as phase change constant. The attenuation constant, where there is a decrease in the wave amplitude over the part of distance, and the phase change constant, which is related to the shift in the wave equations over the particular period of time. Propagation constant, which is related to gamma, which is equal to alpha plus j beta, where alpha represents attenuation constant and beta represents phase constant. For particularly for the good conductors, alpha which is approximately equal to the beta, where alpha which is related to square root of pi f epsilon mu sigma, where mu represents permeability and sigma which is related to the conductivity. Skin depth will be observed in terms of propagation constant, and wave equation will be delayed exponentially in the propagation constant. And coming to the skin depth part, in the skin depth, it is one of the important part in the plane wave propagation in the good conductors. By using this skin depth, we can analyze how the material will be analyzed in depth to the material in the copper and aluminum, where skin depth will be related by the equation eta, which is equal to 1 by alpha, which is equal to square root of 2 by mu omega mu sigma. Depth will be reduced to 37%. The skin depth will be mostly important in high frequency analysis and the millimeter wave analysis circuit. And skin depth will be mostly particularly used to analyze the depth of the electromagnetic field. And compared to the intrinsic impedance, which is given by eta, which is equal to output impedance by input impedance, which is related with the help of electric field and magnetic field. And coming to the application part of plane waves in good conductors, it is used in transmission line, waveguide, shielding effect and RF and microwave system. And coming to the summary part of our discussion, today we have discussed about the plane waves in good conductors. We have studied about the good conductors properties, aluminium and copper, and keeping this equation we have related this to the Maxwell equation. From Maxwell equation we have derived the wave equation. After that we have related the propagation constant, attenuation constant, phase constant and skin depth and intrinsic impedance also analyzed. At last we have discussed about the application part. These are the references I have taken for the good conductors. Thank you.